Okay, so today I'm going to solve the problem number 746, minimum cost climbing stairs. So you are given an integer array cost, where cost of I is the cost of the ith step on a staircase. Once you pay the cost, you can either climb one or two steps. You can either start from the step with index 0 or the step with index 1. Return the minimum cost to reach the top of the floor. Okay, so we are given something like this. So we have step 0, we have step 1 and step 2, and we want to reach to the step 3, which is at the top, and we can take uh, maximum of 2 steps and minimum of 1 step. So we can take either 1 step or 2 step. Okay, and the cost of using the steps are 10. For this, here it is 15 and then it is 20. Okay, so to solve this problem, what I can do is I can see one thing, uh, that at any ith step we define one function which will give us the minimum cost to reach that step. So at f of I, so let me write that. So we define f of I as the cost to reach the ith step. Right, now we can reach to ith step via two ways. Either, so previously if I take one step before it, or I take two steps before it, so this would be our function. If I have took two steps before reaching the ith step, then I'm coming from f of I minus 1, I minus 2 from here, and if I'm coming from one step before, then that is f of I minus 1. Right, and one thing that I know is, to use the step I have to pay a price, so which is effectively like this. Like if I'm using this stairs, so two steps before, so the cost of using this staircase is cost of I minus 2, and the cost of using one staircase before ith step is cost of this. So let me rephrase it. So from I minus 1, if I want to reach to I, then I have to pay a price of whatever the price was at this step, which is cost of I minus 1. And so it converts into a typical standard DP problem, where I need to find the minimum of this path. Right, and it will boil down to final two cases, uh, so which are like the minimum cost to use the 0th step is 0, and the cost of using the step 1, because it is given in the problem we can start from a step with index 0 or step we can start with step we can start from index 1. So the cost at starting for both is initially 0. So this is our states for this problem, and we just have to write it out, and we'll good to go from there. So let me show how can I write this problem. So we define our states, so which is something like this. So if my so first the n is length of the number of steps that I have, and if n is 0, then we want to return 0, and if n is 1, we also return 0. These are base cases, and we define our DP array, which will tell us the cost to reach to the top, and that would be, and let's define our initial states in that DP array. So our DP is like the cost at the using the step, the cost to reach the 0th step is 0, the cost to reach first step is also 0, and from there we'll start using the steps. So this is our total initial DP array, and we want to reach to the top. So for that we will write using the DP equation that we just created before, 2 to up to n plus 1. So at any step is nothing but minimum of cost of that from where I came. Cost of I minus 1 plus dp of I minus 1. So I can dry run it if you want, and let's see, that's how it will look. So if you want to find that second, so dp of 2 would be minimum cost of I minus 2 is cost of 0. And so for convenience, let's say c0 and plus dp0, which is 0. So and the other two are cost of one plus dp1, and we have to take the minimum out of these two. So minimum of these two is, it is look like this. The cost is 10 plus 0, and the cost is 15 plus 0. So the minimum of these two is 10. So the dp at second index would be 10, and similarly we'll calculate for up to the till top. So that would be 15. We can see that by printing it out, and we want to return the top when we reach to the top. So that is dp of n. Let's see, and let's submit it. Okay, it's passed. So that's how we solve this problem. Thank you.